we'll get started, and then if others come on, they'll jump in. So what I'm going to talk about today is debugging pgSQL. For those of you that were in the tutorial the other day, we talked about how you could write a lot of pgSQL. If you were in Joe's talk next door, talking more about writing functions, this is about how do you actually debug them. So who am I? I'm Jim Wiljenski. I'm a director on the U.S. Postgres Association. That's a nonprofit here in the U.S. that advocates Postgres usage. So we do things like we just did a PG day in Austin this last Saturday. We do, for coming up in March, there's Scale, Southern California Linux Expo. There's a big 2-day Postgres event. We have a big Postgres booth there at the expo. We'll get a couple kegs of beer and talk about Postgres with all the people there. And then the big event is in New York. It's actually Jersey City this year. End of March, a big Postgres conference. Check out postgresql.us and you can go find out all the different things that we're doing there. Don't get put off by the website. It's not the prettiest one. We're database guys. We're not web developers, so it's informational, not for aesthetics. I'm also co-organizer of the Philadelphia and the New York City Postgres user groups. So we do the monthly meetups. We try to do monthly. It's more like 9 or 10 a year that we do in each one of them. And trying to grow the local user groups there. I think Philly has about 650 people in the group, and New York we're about 2,000 people in that group now. And for the day job, I'm the CTO of OpenSCG, doing Postgres consulting and support and stuff like that. So why am I doing this about pgSQL? I've been doing all talks on pgSQL over the last year quite a bit because the Postgres world is changing a little bit. We're getting a lot of people inside of Postgres who are more web developers. Postgres is just kind of hockey sticking on usage, and you're getting people who are playing with NoSQL, but it doesn't give them everything they want. People are coming over from MySQL. You get a lot of different people that are more web developers coming in there, and they don't really understand the internal Postgres databases or databases in general. So they take their knowledge of coding and put it inside the database, and that's just wrong. Right? It's just not the way that you would do it. You also get a lot of wrong assumptions that people think that let me write all my code with stored procedures, it'll stop SQL injection attacks. It's not actually true. If you write bad code there, you could still get SQL injection attacks. It's a coding practice and how you validate your parameters. And also we're seeing a ton of Oracle to Postgres migrations these days. They've always been there, but they're accelerating. And Larry Ellison made the decision back in the 90s, let's tell everybody to write all their code inside the database so people have these tens and 100,000 lines of PL SQL code, so they think that's the way you write your applications, is write it all in the database. So now you have all that code moving over to Postgres these days. So that's not necessarily true. You don't always have to write it all in the code. It's better to put it out in your application server, a lot of things. But there's a lot of code there these days of real full business applications inside of the database. So for this, I need an example data in order to be able to go through things. I've given this talk a few times before. I'm a football guy. I like football. I contemplated changing some of these slides to use election results, but that would be way too controversial. So I stuck with the football slides, which is fun when I do it in Europe because I have to describe what American football is. I have to describe what a yard is, right, out to the rest of the world. And I just like the Dallas Cowboys. I'm a Washington Redskins fan. So I like to make fun of the Cowboys. I think Joe does too because he's a Giants fan. But you have this simple problem of, the manager comes along and says, find the youngest rookie. And when I'm in Europe and when I had to do this talk over in St. Petersburg, Russia, I had to describe what a rookie was. When they were it's the first year that they're playing. Youngest rookie to rush for 100 yards against the Dallas Cowboys. Right? You run that, and I have picked some data out of the NFL stuff that went back from like the mid-90s to to about 2010, 2011, and Edwin James and Jamal Lewis popped up that they were both 21 years old when they did it. Now, a database developer, somebody who understands SQL, this is a little bit of an eye chart for people in the back, might write something like this. They write a function to do it, right? And they'll use return query, and you could do it all in a single query, right? You use the with clause as a common table expression. You even have a little windowing function down here, right? And you could get those answers as a single function, right? If you're really good with SQL, if you understand SQL and you think like a database developer or SQL developer, you could do it in just a single query, right? A web developer doesn't think that way, right? So what I'll happen to say, okay, I'll write a function that give me all the backs that ran for at least that 100 yards against the Dallas Cowboys. So create a function to get backs against team in yards, right? And they'll loop through and get all the games that Dallas was involved in. And then they'll open up another one and find out, all the players in there that were running backs for that game. And then they'll go in here and do an if statement and say, was it actually on the Dallas Cowboys or not? Because we want the ones that were against the Dallas Cowboys, not on the Dallas Cowboys, right? And then they'll return that list back, right? So they'll have this function here, is on team, which will go ahead and tell whether or not it's actually on the Dallas Cowboys or not, and they'll call that, and it's nested within there, right? But we really want to get all the rookie backs, not just all the backs. So they'll write another function that'll call the get backs function, right? In order to pull out all the rookie backs. And then you create this other function, is rookie year, right? This is how you write good application code. You kind of piece it out, you put it into nice module little pieces where it's more maintainable, right? And it makes it so this way it's easier to maintain that code going forward. So they follow those same practices inside the database, and you have this is rookie year, right? And so you have this function is good rookie year, and find out is it the debut year is the same year as that game, right? It makes them the rookie. And then you want to find the youngest rookie back, right? So you take that list of getting all the rookies and you find out what's the youngest year, the youngest age for all the rookies, right? So we'll loop through that, and then we'll loop through it again in order to find out of those, which one has that same year, right? And then we actually want to return the player name. So we have another function that says get the player name, right? Because that's a good programming practice. You take something like get player name, you push that out into another function. You don't just join to another table to get it. You create a function to do it, right? So you get that player name, right? And return one of them, right? Because some of them might have, names change and stuff like that throughout the year. Ocho Cinco is one of the guys that like to change their name from Chad Johnson, right? It's sometimes players' names change throughout the year just because they can. Right? So how do you get like this? It really comes because nobody thought to write it that complex or that silly. Somebody created a function in order to do a specific thing, and then they leave. And then somebody comes in and they don't want to fix that function that was right there to add the new functionality. They have another function, call that function, they create a new one, and then they call another one, and they call another one, and over the years, you get this giant call stack of functions inside your database, usually by people who are kind of new to Postgres, right? It's not somebody that really has a lot of experience in it, because Postgres is still growing. People are still learning Postgres. They don't understand, I shouldn't do this and I shouldn't do that. I should do it this way and not that way. So you get some people that are knows Postgres just enough to be dangerous in order to create functions like this, right? They're good programmers. They understand programming concepts. They could understand the syntax inside of Postgres and learn that in Google and look at the documentation, but they're not understanding how Postgres works under the covers. So they end up with code like this with giant call stacks and thinking more like a web developer instead of a database program. Thinking back to that first one, we could have solved this whole problem with one SQL query. So that's why I give this talk, right? Is just to get the point across that when you're doing things inside of Postgres, inside the database, you're doing it a little differently than your web development. Just because you could write things like JavaScript inside of Postgres, you're not writing it the way you are on your application server, on your web servers. Postgres, remember, is single processed, so when you run a query, it's not going to parallelize anything, even though in 9.6 there's parallelization in there. You're not going to parallelize your function execution in any way. You're not going to be able to take advantage of the things you do in web servers. So think of it, you're writing things in sets. What data you want to get out, not as a functional or object-oriented language the way you do in application servers. So continuing along with the football thing, it's fantasy football is all the rage. And the people in Europe just couldn't understand fantasy football. They rightly pointed out it's legalized gambling. But it's, it's for the football nerds like myself who like the numbers, like watching the games, and get overly involved in watching the games because you want to beat your friend. But using that for an example of a good way to do some business logic. Right? Fantasy football has business rules. If somebody throws for a touchdown, they get 4 points. Every 25 yards they throw, they get 1 point. And if they throw an interception, you lose a point, right? Same with the rushing and receiving. So you have defined business rules for fantasy football. Right? We could score a game the same way you would calculate a credit score or other things in the business world. We're scoring a game for all the users, all the players in that game. For this, and we also need a simple schema, right? Not the most elegant, but it's the way the data came over, and I didn't want to massage it in any way. And also, if it's the most elegant, it wouldn't be much to debug now, would it? Right? So we got a player table and a games table. And then we have everything split up the rushing, passing, receiving, and touchdowns tables. And we also have this little teams table over here for all the teams and when they kind of move around. So we need a couple of procedures or functions. We have something to calculate the rushing score. Right? Is you take in a player, a year, and a week. Right? So this way we can calculate the score for the rushing yards for that given week. And we could do that as a simple select statement, right? For every 10 yards, we get, we get 1 point. Ideally, we should probably pull this out somewhere else, so this way it's not hard-coded. So next year when they change the rules, we don't have to change our stored procedures, but this is more of a demo. And then if it's null, we return 0. Fairly simple procedure. Then we want to calculate our player game score. So, if you're a quarterback, you could potentially have passing, rushing, and then your touchdown score. Running backs, rushing and touchdown. Really, because been pointed out at other times they could have receiving touchdowns. Right? But you have something that calls those individual functions. Then you want to calculate your average yearly score, because sometimes when you're doing your drafts the following year, you want to find out what their average scores were the year before, right? So you need those kind of summary and statistical functions on what's happened in the year. Same way you want to do year-over-year sales numbers. You want to be able to see what it is year over year, right? So this also throws people for a loop in Europe of why are you looping over 17 when they're dividing by 16? Because you have that bye week where they're off for 1 week, right? This is, they're fascinated by American football, more so than the pgSQL in St. Petersburg this summer. Right. And then you got, so when you want to debug something like this, the normal thing that people see is let's put in something like raise notice. Right? So this way, we'll run that function, and we want to see what the yardage score is at that given point. We'll do a raise notice, and it'll spit out a debugging message when you run it. Right? And we can see what the value of yardage score is at that particular point in time. Right? So if we ran select passing score for Drew Brees on the 5th game of 2005, we could see he had a passing score of 8, a touchdown score for 4, and an interception score of -2. So his total passing score was a 10. Right? So this way, you could debug that old tried and true method of putting in debug statements in order to see what's spitting out. It works, always does. It's a great way of doing it. Better way, it's a debugger. Actually going to try a live demo, which is something you usually don't do in things, but I'm going to give it a shot. I got backup slides, just not. But Postgres has a PL debugger. It's been around since 8.2, been around a long time. The code is right here at git.postgresql.org for the debugger. It's fairly simple to build. You do a make install, and as far as I know, the only place that we could get the binaries from is, we put out a Postgres distribution and call it pgSQL. You can get it here. You can get it over the postgres.org page and look for pgSQL. We build a debugger because we feel as though it's kind of important. But when you do it, the first thing you have to do is set shared preload libraries. If you were in Joe's talk, the last section talked about shared preload libraries. You have to do that in order for it to work, and then you do the create extension. So let me try doing a demo of this. Let's see. Well, this is not the easiest thing to see from over here. Let's do one of these. Should have just mirrored my screens. All right. So the debugger has two pieces to it. It has it has the plugin that you'd use for on the server side, but you also have a piece that's part of pgSQL, part of pgadmin 3. I'm sorry. All right, so I'm trying to bring that over here into this other window, and it's not cooperating. There we go. Just got to catch you. Come on. There we go. All right. I should have just mirrored my screens and been simpler. One more time. Come on. All right. So when you have pgadmin 3, you're connecting to your database that you've created that extension for the debugger. You have it installed, it's there. So then you could come over here and look at all your functions which are up here. Right. So you have something like here, your passing score. Now if you want to debug that, once you have everything all set up the right way, this debugging tab, which is normally grayed out, now is something to it. Right, so you could go ahead and say debug. Right, and the same thing happens here where it pops up on my other screen. And I'm sure when I hit the debug button again, all of a sudden that's not going to work either. Right? So it lets you type in values here for your parameters. So we'll do Drew Brees. Right? In 2005 and 5. And we say debug. And yes, it did pop up over here. So now what you have is an interactive debugger called with those parameters. And now that went to sleep. There goes live demos, huh? Let's try this. Nope. That just didn't like it. No, a second? Okay. I'm going to redo it. Okay. Okay. just when I got to the good part of being able to step through the function.
I've got a question.
Sure, shoot.
Why don't women like to date Cowboys fans?
Why?
Because then they'll never get a ring.
I like that one. But the debugger, when you have these simple functions like we have now, you could put those raise notices in there. Works really well. When you see us stepping through them, when you have really complex functions, we have some customers that have 100,000 lines of PLPG-SQL that have just tons and tons. They put basically their whole application inside of the database. So it's and understanding where the problem is, it's like you need something like this. Yeah, go ahead, David.
Is there anything on the horizon about like making PLPG-SQL compilable, or
Jan's talking about it all the time, right? So it's there are certain cases where people who have, because one of the things about PLPG-SQL is it gets cached every time it's run per session, right? So it doesn't pre-compile it. You run it and it's cached inside the memory. And when you have something like 100,000 lines of PLPG-SQL, some complex stuff, and you might have 500 connections on a database, and that's all cached, you're all of a sudden have a ton of memory just soaked up using your, just caching your functions inside of memory. So compiling it, so this way you don't have to cache it like that all the time, and you just have a single compiled version for the entire system, it would be ideal. Problem is, Jan's convinced there's something with MVCC with the functions that there's a little bit of a problem. Oh, there we go. I'm going to try to mirror those displays, and hopefully it doesn't all go away. There we go. Now, all right, still sitting there in the debug mode, which is good. All right, so now from here, what we could do is we could step through it, and as you can see down here, even though it's a little small for those in the back, we just set score to 0, so that got set to 0. And we run that, and the yardage score is 8. Right? And then as you step further, come on. Yeah, there we go. Big old fingers of mine aren't getting the buttons the right way. And then you can just kind of continue through and get 10. Right? So what you could also do is while you're going to debug that again, you could actually go ahead and say it wasn't supposed to be an 8. You've realized it should be a 10, right? So this way, as you're going through, it actually changes the value for you. So this way, your return is actually different. So if you want to, just the way you would a normal debugger inside your Java code or other things, you could actually change the values along the way, which gives you some power. If you think there's a problem, you want to be able to isolate it, or if you want to go into an if statement and you're not sure how to get the right values, you could just make that value true so it goes inside the if statement for you. Right? But which is really cool, being able to step through those sorts of things. But really, one of the really cool things I like is that it has a global breakpoint. Right? So it allows you to do things like debug triggers. So if we went up to this Teams table here, it has a trigger on there called the Teams trigger, right? So if we click on that, and we say set breakpoint, what this does is pops up a global debugger. You have to be a super user to be able to do this. But what it does is it sets a breakpoint inside of that trigger, that the next time that trigger's run, it's going to go through the debugger. So what I could do is open up another session over here in PLPG-SQL, right? If I did something like this of, say the Raiders are actually going to move to Vegas, you update the city, right? All of a sudden now in the debugger, this global debugger in a completely different session, we're able to see that trigger code. As well as down here, seeing all the internal values of a trigger, of name, when, level, TG-rel ID, TG-op, you could see all those different values as they're coming in, right? And it lets you step through them, right? And then you do that raise notice, and it's actually interacting over here and says who's moving now. So this way you're able to debug your trigger code. And even if you have cascading triggers, you could set that breakpoint in order to be able to do that. You could do that in functions or on triggers. So this way you could set that global breakpoint and run your main application from a browser, from a URL, and be able to debug your code under the covers in the context of how you actually call the code. It just, don't do it on production, because the next person that actually hits that function, you'll be debugging, and it might take 5 minutes for you to step through it, right? And all of a sudden that thing seems to take a long time. So any questions about the debugger? I'm going to stop with the demo part of that one. Right? Yeah, it's all on my laptop, but it makes a libpq connection. So you could be running pgadmin on your laptop and connect to your database server somewhere else. No, it goes over 5432. It's just a normal database connection. Yeah, there's a very crude C++ front end inside of that code base in that Git repo. But yeah, pgadmin 4 is implementing it, but it's still shaky. The pgadmin 3 interface is much better for it. Right? And it's all calling functions, so this way you could actually do it from the command line if you really wanted to. No, because event triggers, you can't really do it on pgSQL. This only works with pgSQL, right? And they're kind of new at this point. Right? Well, event triggers, I think we can do pgSQL, but not very much with it. I've never tried. I don't know if the hooks are in the right places in there to do it or not. Right? Give it a shot. Any other questions about the debugger? The 2 times I tried it, it crashed both times. So, no, they're working on it. pgadmin 4 is still relatively new. pgadmin 3, been around for well over a decade. It works. Cool. All right, let's see. Let's go down to where this thing kicked off. All right, so I had screenshots just in case it didn't work, and I almost needed to revert to them. Okay. So going back to that raise piece, sometimes when you create your functions, you don't just call them. What you do is you use them in a SQL statement. So you might get things like this, where you're going to have the average yearly score inside your where clause. Right? Or here's a from clause, right? Something like average yearly score, when it's in your where clause, if you're doing a full table scan, this is going to run once for every row in your table, right? So when you put the raise clause in there, you get like this in your logs, and it's basically meaningless for you. Especially if you got 1 million rows of that table, you can't tell anything that's going on, right? So you need to, in those types of cases, you need to be able to dig in a little bit of what's going on and where the problem areas are in that function. Because usually when you're doing stuff like this, you're doing it for more performance tuning. Right? One way to do that is to set track functions to PL. Right? This is in your config file. You could do it at the session level and just do a set track functions, or you could set it globally in your config file. And what it does is it populates pgstat user functions. Right? And this way you could tell which function ran, how many times it ran, the total time, and what's the self time. So that means the average yearly score here has a self time of only 13, but a total time of 7,000. That means it wasn't in there very long. It kind of passed it off to somebody else. Right? Most of the time was used in one of these other functions right down here, the receiving score. That's the biggest one there. That's part of base Postgres. You could use it now and just turn it on in order to understand what functions are being called inside your system and which ones are taking the longest amount of time. What really you want to do is dig down into that a little deeper because those are just black boxes. You could use this track functions. You use pgBadger. pgBadger to see what the slow queries are on your application. And inside of pgBadger, it says select star from some really long function. And it doesn't really help you very much. Right? So there's also a PL profiler. Right? So this, you could get it off of this Bitbucket repo. Or again, it's in the big SQL distribution there. It follows the same code base as the debugger, which is why you have the same preload libraries. Right? And then you do a create extension PL profiler. I'm going to be brave and try to do another demo of it in a few minutes. But what that does is it creates, again, like the back end pieces of it, but also a front end PL profiler command line utility. So what it does is it allows you to run from the command line profiling of your database code. Right? It has the normal options that you would expect with Postgres to be able to connect at the command line, the -H, -U, -D. Right? But you have these other ones here of in-memory data, or do you want to persist it over time? Really, if you're going to be just looking at a single function versus looking at this for setting up the monitor over the course of a night. So we could, again, run it just for a specific instance, or we do this sometimes on applications of, say, monitor. And what that'll do is monitor and record and profile all your function calls throughout your database for whatever period of time that you want to be able to run it for. A lot of times if you're in a performance test, we might kick it off the monitor before you run the performance test, and so this way you can analyze it after to find out really where your slow queries are at. Right, so we have this function here, again, that average yearly score, right? And then let me just, again, be risky here and try doing that again. Right, so if we did this. Turn timing on, right, for people new to doing things inside of PL SQL. Let's see, can I make this bigger? There we go. You turn timing on, so this way you could see how long a specific query takes to run. Right, so we turn that on. It chugs along for a little bit of time, and it should, in about 6 seconds or so, spit back the result. Right, 7 seconds, right? If you're looking at the debug logs, it's going to be really hard to tell what took so long. At least we have an idea inside of that track functions, the pgstat user functions, that it's in the receiver function. And that function's not overly big, so we can kind of pin down what it is. But when you're looking at a function that's about 10,000 lines long, it gets kind of difficult. So what we can do is, let me try. Take this and run this through the profiler. Right, so this basically is profiler run, what's the connection information, the query that you're going to send in, and where am I going to output it. Right. Right, and then it's going to pop up a little editor in a second, right, where you could change little things in the HTML that's outputted, right? But then now we should have the run.html. So if that open it up here, right, it produces a report for that query that was just run, right? And we can see the different call levels here. We have average yearly score here is taking up the most amount of time, but when you look at it, the game score is right above it. This flame graph is only showing that this thing doesn't take much longer than this, but it's really these three functions that are taking up all the time. Right, so it's really going back to that receiver score. So if you click down here on the receiver score to find out what it is, and then we click on show, it shows the actual query itself and highlights the row itself that's taking the most amount of time. So this select statement in there, down here, is taking up 99% of the time. Right? So this way you're able to pinpoint it right inside the function what's taking all the time to do. Right? Again, this is a fairly simple example. Just looking at that function, you would have guessed that takes up all the time. But when you have, again, 10,000 lines in there with very cryptic code that's not commented very well, it saves you a ton of effort in order to be able to find it. Right. So where we actually use this in an actual customer use case. We've been working with a customer for a couple years now. They do some, the ones that have the 100,000 lines of pgSQL. They essentially run their entire business inside of a bunch of pgSQL functions. It was written by some really brilliant Java coders, but they thought that recursion inside of Postgres was kind of fun. So they have this thing that audits a ticket. It's really an auditing system that calls a lot of other functions, and the normal thing of as you add more functionality, you create another function to go do it. And in order to audit a specific ticket, sometimes it would take 10 or 15 minutes to run for one single ticket. We looked at it, we were looking at it for months in order to be able to track down what it was, and trying to piece out what it is, putting debug statements all over the place in order to be able to find what's actually taking so long. We looked at all the SQL statements. Everything seemed to be using indexes. When we ran it, there was no sequential scans, nothing. Put the profiler on there and said, let's see what's going on. Right? And this is the call graph that got spit out, blurred out most things. But what it is 8 call levels deep and also 9 call levels deep, there's this function called getNewSequence. They were called, this one 5 million times and this one 8 million times. That function itself ran in a couple milliseconds. Never popped up in anything as being a long time. But for this particular ticket, it was taking up 80% of the time of the overthink. When you're looking at the flame graph, the top 2 pieces of that's, this one 8 levels deep is 40% of the time, and this was, 42% of the time, that one function. So as we dug down into it, we looked down in here, there was this SQL statement, a dynamic SQL statement inside of a loop that's taking 99.91% of the time in that overall function and got called 8 million times. So we looked at it, we're like, well, it looks like there's an index on it. It turned out on that particular SQL statement, look, we even had the raised notice. We knew we were right there. We had an idea, it was a raised notice. But because it was all called 8 million times, we never really saw anything that was there. It was just flooded the logs. Right? But what it turned out in that particular case is that the order of the indexes, the columns on the index was off. So we didn't have the first column in the index the right way. So it was doing a bitmap index scan, not an index scan. So on all the other counters, it looked like we're doing an index scan. Great. We flipped that over, that one function, new flame graph looked like that, where this now ran in 1.6 seconds for the whole function. We basically doubled their throughput in 10 minutes when we ran it through that, just because everything was bottlenecked through that one function that we couldn't find for months. Right? It's, the profile, we've done that at a few customers now because you have this historical pgSQL that's been around for 10 years at places, where people have migrated stuff over from Oracle and didn't rewrite it as they came across, they just did a translation. And it just ends up, there's something in there that Postgres behaves differently than Oracle. Functionally, it's the same, but you have this nagging performance problem, and it's really hard to find the line inside of the pgSQL. The profile lets you do that. So Jan spent a lot of time kind of putting all this together for us. Right? So that's the moral of the story is when you have performance problems inside your pgSQL, it used to be a black box. You could either use a debugger throughout your development tools, development times in order to figure things out. Profiler, you could even run this in production. You could have it enabled. It doesn't have any performance impact unless you run it for that particular session. So you could have it enabled in your production servers and only use it when you need to. Like I said, you could just run it for that particular query. You could set up monitoring for it. There is overhead while it's running. So in that particular, that one query is going to run a little bit slower than if you just ran it through pSQL. Right? If you got your Postgres from the Yum repos or the apt repos, you could just build it. It's fairly simple to build, right? The make install. There's no special way of building it. You just need a development environment to do it. But don't put the debugger in your production environment unless you have to, because that is a performance impact in there just having it on there. The other thing, it uses the same hooks inside of pgSQL. So you can't have them both at the same time. We haven't quite solved it yet. So a lot of the other hooks inside of Postgres, you could kind of save off the reference to the other one. Because of how it's, pgSQL is dynamically loaded, right? You don't necessarily have to have it there yet. We have to do some things with the variables. So this way, those hooks aren't the same as the rest of them. So we can't run them both at the same time. So this way, that's why we have to do it's either one or the other. So any questions? I'm not going to try any more live demos.
Would it be worth it until that problem is solved, to have one check for the other and just sort of say?
Yeah, I guess so. Right now, it just does throw an error, right? So it's, I'm sure it's going to be solved relatively soon. It's a nagging thing for Jan to fix. Right? It might have to be something in the core, though, that has to get changed.
Does the profile work on sharded tables?
On sharded tables? Yeah, it's independent of tables. It does it at the function level. So if you want to be across multiple databases itself, what you can do is collect them all on the sharded systems. And if you go back here, they have an export command that exports all the data, and then you can import them all into the same thing for analysis. So what we do in production systems is monitor it and then export out of that and then run all the analysis on our laptops and not run the analysis on the production system. But it allows you to, this way you could consolidate everything across sharded systems if you want to.
Pretty irrelevant, but why did you name these tools this way? So you're not using the name.
Yeah.
Why PL profiler instead of PG profiler or something? Same thing applies to the department.
Yeah. Why? PL Profiler I can take credit for because I did the first incarnation of it, and then Jan took it and made it work. It's just procedural language profiler. Our hopes are to add these things, add the right hooks into Perl and Python and Tickle, so the other built-in languages would work with the same mechanism as well. That's the future plans of it. Since Jan wrote the Tickle one, I have a feeling he'll do that next one, even though nobody ever uses Tickle except Jan. Any other questions? Thanks, everyone.